Here we are. Math Tidbits number 7 are ready. And what I'm going to do with this particular set is introduce and prove the rules for derivatives of sum of two functions, of a product of two functions, of a ratio of two functions, and also discuss the chain rule. All of these are, again, things which we need to be familiar with in the first semester of physics, and so I'm taking the time to lay them out here for you. We'll introduce them slowly in class, but they will eventually need to be part of your toolkit. So I'm just going to put this as derivatives of more complex functions. And we'll begin. So a very simple case, one which follows exactly what you would expect, is let's suppose we have a function h of x, which is just the sum of f of x and g of x. And you're going to expect, of course, that the derivative of h is just the sum of the derivative of f and g, and you're right. But to show it explicitly, let's remember, fundamental definition of a derivative is the limit as delta x goes to 0 of f of x, of delta f divided by delta x, and that will be 1 over delta x times f of x plus delta x minus f of x. So that's how we've defined it. And when we have used this principle previously, we've started by calculating the difference in the function h. So we'll just call that delta h. That's h of x plus delta x minus h of x. And we will calculate this and then divide by delta x and then take the appropriate limit. So this is just f of x plus delta x plus g of x plus delta x minus f of x minus g of x. All right, well, this is just then taking what seems to be suggested here, the difference of f of x plus delta x minus f of x, and then add that to the difference of g of x plus delta x and g of x, just rearranging those terms. So that's delta h. We then take and divide delta h by delta x, and this then becomes, right, this is delta f, and this is delta g, and so this is delta f divided by delta x plus delta g divided by delta x. We take the limit as delta x goes to 0, and that will produce dh dx. On the left, the limit of this is as delta x goes to 0 is the definition of df dx, and likewise dg dx is the second term. So there we have it. There's the sum rule, the rule for sums of two functions. All right, next we will take products. This is a little bit more involved, but similarly straightforward in terms of the method. So we're going to let h of x equal f of x times g of x now. So that delta h is equal to f of x plus delta x, g of x plus delta x, minus f of x times g of x. And we then want to do Well, it's not very tricky. We want to add. It may not be very obvious, but we're going to add and subtract something which is useful. F of x times g of x plus delta x. Okay, we can add and subtract the same thing to an expression and not change its value. So we'll do that. Delta h is f of x plus delta x times g of x plus delta x. I'm now going to subtract f of x times g of x plus delta x. I then have my my corresponding addition of f of x times g of x plus delta x. And then the last term here is minus f of x times g of x. Now, if you look closely here, I have some simplification I can make. Namely, I have here g of x plus delta x, and it is, I can factor that out, leaving behind f of x plus delta x minus f of x, that multiplied by g of x plus delta x. And then similarly in the second two terms, I have a common factor of f of x, so I can add f of x times the quantity then g of x plus delta x minus g of x. All right, that's delta h. Now, this is delta f, and this second is delta g. Sorry for leaving that off the bottom of the screen there. You can take a look at it. Okay. So, I've got, now, just to simplify, I've got delta h equals delta f times g of x plus delta x plus f of x times delta g. Okay? Doesn't quite look symmetric, but that's fine, because now what we're going to do is take and divide both sides by delta x. And then we're going to take the limit, so dh dx is equal to the limit as delta x goes to 0 of delta h over delta x. And that's the limit of the above function. Well, I'm just going to write this out in excruciating detail to make obvious the conclusion that we're going to draw. So I've got the limit of delta x goes to 0 of delta f over delta x times g of x plus delta x plus the limit of delta x goes to 0 as delta x goes to 0 of f of x delta g over delta x. So the limit as delta x goes to 0 of delta f over delta x is just df dx. And this is multiplied by g of x plus delta x. Well, that limit is simple. That limit is simply g of x. Similarly, over here, I have the limit as delta x goes to 0. Well, f of x doesn't change. And the limit as delta x goes to 0 of delta g over delta x is dg dx. So this is plus f of x dg dx. And that is our product rule. When h is a product, then I take the derivative of the first times the second plus the first times the derivative of the second. And that is our rule for products. Okay. Thirdly, and this is getting increasingly complicated, although the process for this will be very, very similar, a ratio. So now let h of x equal f of x divided by g of x. So we can calculate delta h. as before, that's f of x plus delta x divided by g of x plus delta x minus f of x divided by g of x. I'm going to put these on a common denominator, namely the product of the g's here. So the first one I need to multiply top and bottom by g of x, so this will be f of x plus delta x times g of x. And this one needs to be multiplied top and bottom by g of x plus delta x, so this will be f of x times g of x plus delta x. And then that is all divided by g of x plus delta x times g of x. Again, I'm going to do something that seems non-intuitive, although you know kind of what we want to look for. We want to be able to have things where I can factor out an f of x plus delta x minus f of x and a g of x plus delta x minus g of x. So I'm going to add and subtract f of x times g of x. That will give us what we want. So my delta h now becomes f of x plus delta x times g of x. Firstly, I'm going to subtract my f of x g of x, and then add my f of x g of x. And then the last term is minus f of x times g of x plus delta x. All of this is still divided by g of x plus delta x times g of x. All right. Now we note, just looking at, again in the same way as we have before, I can factor out an f of x plus delta x minus f of x, leaving behind of g of x. So I think I'm going to leave this explicitly. F of x plus delta x minus f of x times g of x. And then here I can factor out an f of x, and I have g of x minus g of x plus delta x. Again, the denominator is still g of x plus delta x times g of x. Now to simplify my expression here, this term is delta f, and this term is minus delta g. So what we've got is delta f times g of x minus delta g times f of x, and then still divided by g of x plus delta x times g of x. Finally, divide both sides by delta x. There we have it. And then simplify terms, or put group terms together that we know belong together, like, all right, here I have delta f divided by delta x times g of x minus delta g divided by delta x times f of x, all over g of x plus delta x times g of x. All right, and now if I take the limit as delta x goes to 0 of delta h over delta x, that's my derivative dh dx. And what happens to all of this? That first term in the numerator becomes df dx, and I'm multiplied by g of x. That second term in the denominator here, there's dg dx times f of x. And then the bottom, g of x plus delta x, just becomes g of x as delta x goes to 0. And so I've got g squared. All right? So that's my rule. That's the rule for ratios, is if h is, and this is worth memorizing, of course, as all these are. If h is if h is f over g, then the derivative dh dx is equal to the derivative of the top one, okay, times the bottom one, minus the derivative of the bottom one times the top, divided by the bottom squared. Silly mnemonic I memorized when I was in your shoes was ho-de high minus ho-de ho over ho squared, if you like. Low derivative of the high minus high derivative of the low divided by low squared. Ho d high minus high d ho over ho ho. Anyway, that's very silly, but it works. All right. Last bit is the chain rule. So here's the chain rule. The chain rule says this. This is perhaps, well, I mean, ratios and products and sums, you've got to know all those cold. The chain rule, though, this becomes increasingly important in physics as we go on. Not so much in the first semester, but following. So suppose we have a function f of u, and this u is in fact itself a function of x. Okay, so we have a function of x, and we want to know what is df dx. We don't have f explicitly as x, as a function of x. We have it implicitly as such. And the answer to this is that it is the derivative of f with respect to u times the derivative of u with respect to x. Again, it maybe kind of looks like it makes sense, but I want to give a little bit more of a more than a hand-wavy explanation for this. So if we start with something that we understand in finite terms, a change in f as a ratio to the change in x, simple algebra allows me to insert top and bottom a delta u. And then I can rearrange delta f over delta u times delta u over delta x. Now, if we were to be really mean to the mathematicians, we could simply let all the deltas go to d's, and then we'd have what we've got up here. But we need to be a little bit more explicit, or a little bit more thorough in our discussion. But that said, I'm going to remind us of course, df dx, by definition, is the limit as delta x goes to 0 of delta f over delta x. So this is the limit as delta x goes to 0 of delta f divided by delta u times delta u divided by delta x. All right? The limit of a product is the product of limits. So I can break this into two pieces. Limit delta x goes to 0 of delta f over delta u times the limit as delta x goes to 0 of delta u divided by delta x. This part easily is seen to be du dx. That's the definition of du dx. What about this part? The question, the operative question is, does delta U go to 0 as delta X goes to 0? And the short and sweet answer to that is it has to, it must, if U is differentiable. That is, if U is smooth, the mathematical term for that is continuous, then yeah. Okay? Delta U will go to 0 as delta X goes to 0. So if delta U goes to 0 as delta X goes to 0, then delta X goes to 0 can be replaced by delta U goes to 0 in that first term. And so I have limit as delta X goes to 0 of delta F over delta U. That's equal to the limit as delta U, pardon me, the whole point of this, delta U goes to 0 of delta F over delta U. That's equal to dF du. And now, therefore, dF dx equals dF du times du dx. And that's the chain rule. So the chain rule will come up again and again and again and again and again in our discussions throughout time. So just to give you an example, one quick example here, which you will see when we deal with circular motion and so forth, and even simple harmonic motion. So let's suppose that we have y of t as cosine of omega times t plus phi. All right, now let's give it an amplitude, a constant out front. Okay, so the chain rule is going to need us to recognize that this is some u. So we've got y of u is equal to a times cosine of u, and u is equal to omega t plus phi. So the chain rule says dy dt is equal to dy du times du dt. So dy du, I've got a constant, pull it out front. Cosine u, the derivative of cosine u is minus sine of u. And the derivative of u with respect to t, here's my u. It is just omega plus 0, right? Phi is a constant. So du dt is omega, dy du is minus a sine u. So dy dt, then putting it all together, is going to be minus a times omega times sine of omega t plus phi. That's that. All right? So the next video, number 8, is going to be one in which we do a few examples of various kinds of applications of rules that we've talked about in this video, and that's coming up next.